Good morning, class. We are looking at Chapter 3, Derivatives, Section 3.7. Derivatives of the logarithmic functions. Derivative of logarithmic functions. So we cover derivatives and rates of change, derivatives as a function, derivative as a function, basic differentiation rule, product rule, quotient rule, chain rule, and now logs. Here's the synopsis of that. I'm going to go over that in a moment. And these are various differentiation formulas from the basics, from the definition to the basics to the product rule to the quotient rule, exponential rule, chain rule, and now logs that we are going to cover in a moment. First, reminding you of logs and how they work. Logarithmic properties have been discussed several times. If b is positive and b is not equal to 1, then y equals log x base b is equivalent to x equals b to the power of y. Notice the base is the same for both of them, and the exponent y is the result here. And if you look at this one and the arrow that I'm going to put in, b to the power of y equals x. So going from one format to the next will help us understand the property. So y equals log x base b, or log to the base b of x, is equivalent to b to the power of y equals x, giving rise to the following properties. So let's quickly go over them. Log 1, regardless of the base is 0. Remember, base must be positive, can't be 1. Log b base b is 1. What this means is that if the base and the argument are the same, the answer is 1. Log base b of b to the power of x is x. And all of those, notice, you can go with this arrow. These two combined refer to the fact that logarithmic functions and exponential functions are inverse functions. Log base b of b to the power of x is x. B to the power of log x base b equals to x. This is called the product rule. Log of x y base b is log x base b plus log y base b. This is called the quotient rule. Log of x over y base b is log x base b minus log y base b. And finally, log x to the power of n of base b is n log x base b, known as the power. In the case of a common log, when we use log and no base, that means the base is 10. Therefore, 10 to the power of y equals x. And the transition from the general case to a specific case, in this case, the common log should be very easy to understand. For example, first of all, we drop the base 10, 5, 6, 7 becomes a piece of cake, or number 1 for that matter. I want to discuss number 2. If you look at number 2, because you're not using the base, therefore you know it's 10, you have to put 10. And instead of, and over here, you know the base is 10, so 10 to the power of x. And the base is 10 to the power of log x equals x. In the case of a natural log, instead of log, we use ln, which means the base is e. Therefore, y equals ln x means e to the power of y equals x. And again, the transition is simple to understand. First of all, 5, 6, 7, and 1, just change the log to ln. That's all. Number 2, these two must be the same, the base and the argument. So because ln means the base is e, ln of e equals 1. This one The base is e, so instead of b to the power of x, we have e to the power of x. And the same thing here, the base is e, so e to the power of ln x. So that should be easily understood. The two functions, exponentials and logarithmic functions, are inverse. It makes them symmetric with respect to the line y equals x. Change of base formula. Log x base b is log x over log b. Choose any base, let's say a in general. More specifically, pick 10, common log. More specifically, pick e, natural log. And of course, we go with these two for the sake of evaluation. And as you can from the graph, what does this say? This point has coordinates 1, 0. So at x equals 1, ln x, the y coordinate is 0. When x is between 0 and 1, we get this part which is below the x-axis. And when it's larger than 1, we get this part which is above the x-axis. That's what it's explaining here. All right, let's look at some warm-up examples, reminding you how we can go from one format to the next. How did we tackle this in algebra? We said, okay, let's say this is x, and then 3 to the power of x is 81. We know 81 is 3 to the power of 4. Therefore, x becomes 4. What about log 5, base 25? Let's say it's y. And we are going to say 25 to the power of 1 is 5. 25 is 5 squared. 5 to the power of 2y equals 5. The right side has no exponent. The exponent must be 1. 2y equals 1. Y equals 1/2. Or 25 to the power of 1/2 is 5. When it comes to the last one, we are talking about common log, so we should know log of 100, for example, is 2, because it has 2 zeros. Log of, I don't know, let's say 100,000 has 5 zeros. That's that. Log of 0.1 has 1 decimal, so -1. Log of 0.01 has 2 decimals, -2, so this one has 3 decimals, -3, or you may recognize it as 10 to the power of -3, and that's why the answer is negative. So very straightforward, everybody. We want to write in an exponential format, and all we have to do is just look at this arrow. So clearly 5 to the power of 4 is 625. Seven squared, 49. 1/3 to the power of -4, 81. 81 to the power of 1/4 is 3. 1/2 to the power of -5 is 32. Let me add uh, something. For example, ln of x equals y. With this arrow, remember when we don't write the base for natural log, the base is e to the power of y is x. The different column. Log of m equals n. 10 to the power of n is n. Okay, I just wanted to add those two just so we see both natural log and common log. All right, now what is the derivative of y equals ln x? We don't know yet. We're going to figure it out by rewriting it as e to the power of y equals x. This we know how to differentiate. Any exponential, the answer is itself. So e to the power of y. Look at the exponent. Is a function of x makes it y prime, and x gives you 1. And so y prime is 1 over e to the power of y, or 1 over x. Now, by extension, first of all, the reason we use absolute value of x is because of the domain of logs. For example, natural logs is from 0 to infinity. So we use the absolute value. Of course, the denominator can't be 0. By extension, when we look at the general case, the derivative of ln of g of x, we go with the reciprocal, and then the chain rule applies g prime of x. Now, we simply put g of x instead of g of x u, so 1 over u du dx. It's a different notation, means the same thing, and of course, u can't be 0. Just like x. So that should be very straightforward, everyone. And I hope everybody's okay with that. We are going to move on. We are going to differentiate y equals ln of 5x minus 1. So simply flip it over. That's all. And then what? Chain rule. This is g of x, so you need 5. And you just rewrite it, you're done. 5 over 5x minus. So that's y prime. Y equals ln ln of x cubed can be done two different ways, and I'm going to show you both ways. Number one, just the way it is. Flip this over. Times its derivative, 3x squared. And again, so if it helps, just write down ln of g of x and follow that. In any event, so you got to write this, follow that, rewrite this by simplification, 3 over x, you're done. The second method is to first bring the 3 down. In other words, decompose the log and say y prime is 3 times ln x gives you 1 over x, therefore 3 over x. And there's really not much of a difference between the two simply because this is simple enough. You don't see a hell of a difference. However, the more complicated the log, the easier the second method, decomposing. In other words, if I don't decompose this, I have to first write the reciprocal of that, then I have to differentiate this using the quotient rule. Not a good idea. Instead, I'm going to write ln of the top minus ln of the bottom. Furthermore, this is ln2 plus ln x. In other words, I'm going to decompose this completely. That would be my first step, everybody. And I hope everybody's comfortable with using logarithmic properties. Now, we are going to differentiate, and we know ln2 is a number. The answer is 0. ln x is 1 over x. Please understand, ln2, 5, e, pi, those are just numbers. Minus, flip this over, 1 over 2x plus 1. By the chain rule, times 2. So what you're looking at is 1 over x minus 2 over 2x plus 1. And the product of these two is the LCD, and 1 times 2x plus 1 minus 2 times x. I'm assuming everybody's okay with the algebra. This is the only calculus step, everybody. This was done with calculus. Everything else is algebra. And so we get 2x plus 1 minus 2x. Answer is 1 over x times 2x plus 1 as the final answer, and we are done. Y equals 5x times ln x squared. We can tackle it the way it is, but it's a good practice to decompose this, put the 2 in front, and that makes it 5x times 2 ln x. And the product of these two is 10. So 10x times ln x. Again, you can separate the 10, put brackets, and differentiate and keep the 10 out. Or makes no difference in this case. Say this is f, this is g. You're going to use the product rule. F prime is 10 times g is ln x. G prime is 1 over x times f is 10x. I take the 10 out. This gives you ln x. And this one, by the way, the x and x in the top and the bottom, they cancel each other. So it's just 1. y equals ln x over x, you use the quotient rule, f over g. So f prime is 1 over x times g, which is x, minus g prime, which is 1 times ln x, and just write the denominator squared. Done. These two cancel each other, we receive 1. So we get 1 minus ln x over x squared as the final answer. So this is natural log of this times this times this. So ln of 3, if you look at number 5, the product rule, ln of 3 plus ln of x plus ln of this piece. Let me actually do this in two parts. Ln of 3 plus ln of x plus ln of the last piece, x plus 4 to the power of 5. 5 sits in front. That uses number 7. If you can't decompose this in a split second, that means you're uncomfortable with logs and its properties. ln 3 is a number. The answer is 0. ln x, 1 over x, plus 5. Flip this over. We are going to go with this one. ln of g of x is 1 over g of x, 1 over x plus 4, times g prime of x. The derivative happened to be 1, but you write it just to be on the safe side. So this is 1 over x, this is 5 over x plus 4. Now, before we move on, this is the only calculus step, everybody. This was algebra. This is algebra, and now the rest of them. So the common denominator is x times x plus 4. 1 times x plus 4, 5 times x. I'm assuming we can add up two fractions. And so we end up with x plus 4 plus 5x, where these two add up. If you don't decompose the log, you have to flip this over and then differentiate this. That takes a much longer time. Okay. Differentiate e to the power of 2x times ln x. Notice it's the product of two functions, so you put a raised dot in between. And this is f. This is g. And you're using this. If you want, you can write f of x. You can write g of x. And now find f prime, find g prime, if you want to do that. And then separately put them in, or in one shot. So f prime is the same thing, e to the power of 2x, because exponential, times 2 by the chain rule. So that's f prime times g ln x. Now g prime is just 1 over x times f e to the power of 2x. In other words, you have f prime here times g plus g prime here times f. You take a common factor of e to the power of 2x out. This gives you 2 ln x. This gives you 1 over x. And we're done. If it helps, you can write this one as e to the power of 2x times 2. This one as 1 over x. And say f prime g minus g prime f, if it helps to do it that way. All right, we want to take the derivative of log where the base is no longer e. We haven't done that before. So how do we do that? Change of base formula tells us that log x base b is ln x over ln b, and ln b is a number. So we rewrite it in this fashion so it becomes clear this is a number. 1 over ln b is like a number 2, 5, 10. So if I differentiate that, I get the same number times the derivative of ln x, which is 1 over x, and I put them together. So first and foremost, I'm going to change square root of x to x to the power of 1/2, so I can use number 7, the power rule, and bring the 1/2 in front. That's the first thing I'm going to do. So I'm going to differentiate now. I need the 1/2. It's not going anywhere. I'm dealing with log, so I'm going to flip it over. I'm dealing with a base other than e, so I need 1 over ln b. That means 1 over ln 3. And I'm done. I'm going to just rewrite it as 1 over 2x ln 3. The reason I write it in this format, and I put the 2x in front, if I put it here, if I put 2 and x here, one may read ln of 32x. So that's why we put it in a format that it becomes clear what we are dealing with. What about this one? Well, we have the same situation as here, where the base is not e. Also, we have a function of x. Therefore, not only we have the reciprocal 1 over f of x, we also have f prime of x by the chain rule. And the reason we have 1 over ln b, because the base is not e, putting them together, we get 1 over f of x ln b times f prime of x. However you want to put that, but that's the final answer ultimately. So flip it over because you can't decompose it. Flip it over. Now the derivative of that one by the chain rule, 2x. Now the base is not e, 1 over ln b, 1 over ln 5 by the logarithmic properties, more specifically change of base formula, put them together. 2x over x squared plus 1 times ln 5. Ln of sine x. We write this formula, ln of g of x. I want to differentiate. I get 1 over g of x, 1 over sine x, times g prime of x. The derivative of sine is cosine, everybody. And therefore, we get cosine x over sine x, which is cotangent x. ln of 5x. I've seen sometimes students get confused, so I'm going to call this g of x. So first I need 1 over g of x. I'm going obviously with this. 1 over g of x, 1 over ln of 5x. Then I need g prime. So I'm going to write the g prime here. G prime is 1 over 5x times 5. So 1 over 5x times 5. So if for any reason you're working on a question and it becomes confusing, just take the confusion out by defining it. Define ln of 5x and as g of x. So this one cancels out this one. The numerator has only 1. The denominator has ln of 5x times x. We put the x in front, again, just because otherwise it's awkward. If you put the x here, one may read it as ln of 5x squared. Definitely not a good idea. All right, y equals 1/2 ln of 1 plus x over 1 minus x. This is clearly an example that you don't want to go the way it is and differentiate. So what do you want to do? You are going to decompose this using the quotient rule. Ln of the top minus ln of the bottom. So you have 1/2 outside the brackets, and then ln of the top minus ln of the bottom. Ln of 1 plus x minus ln of 1 minus x. If you don't go this route, you keep the 1/2, you flip this over, which is not difficult. Then you have to differentiate this using the quotient rule, and it is really not necessary to go that route. Okay? It's much better to decompose it. So learn decomposition of logs. So with that being the case, 1/2 remains. This one you flip it over. You get 1 over 1 plus x. And then we are here. We are looking at the derivative of ln of g of x, so 1 over g of x times g prime. The derivative of 1 plus x happened to be 1, but write it. It has no bearing, but write it. Minus, going back to this one, flip this over. G prime. Now, here's the reason you wrote that, because over here, the derivative of this parentheses is -1, and it does make a difference. In this one, it doesn't, because 1 times anything is itself, but in this case, it does. So the result is this fraction is 1 over 1 plus x. This fraction is plus 1 over 1 minus x. Okay. So that's why definitely you want to write this, because this makes a difference. So 1/2 times. Now you have two fractions you are going to combine. Even if in MOB, my open math, they accepted, it's not acceptable. It is not finished. So you take a common denominator of 1 plus x times 1 minus x. And then you say 1 times 1 minus x plus 1 times 1 plus x. Notice again, everything that I do is algebra. This class was the only calculus step. Everything else we do is algebra. So 1 times 1 minus x plus 1 times 1 plus x comes to the top, and the bottom is the product of these. The bottom is 1 minus x squared, right? Because a plus b, a minus b is a squared minus b squared. So 1 squared is 1 minus x squared. The numerator is 1 minus x plus 1 plus x. So the numerator simplifies simply to number 2. Number 2 and 1/2 cancel each other. So the numerator simplifies to just 1, and the final answer becomes 1 over 1 minus x squared. And that's the final answer.